The Fructus network is composed by an exporter and a refrigerator organization. As we can see on the physical architecture, there are two organization servers where each one has a blockchain peer. Also, both organizations have client devices that consume data from the peer. The refrigerator organization have IoT sensors to gather data from the environment autonomously. The framework used for generating the blockchain was Hyperledger Fabric. For every organization in the network, this framework generates a peer, a certificate agent, a channel chain code, and a CouchDB database. Using Hyperledger Composer, an API was generated for every peer to consume and generate data. Due to the lack of support for tasks on a second thread, an external cron was created to monitor processes. The iOS client app provides an interface for users to interact with the blockchain. In a real-world implementation, there should be one client app for every organization, but for simplicity, one application was created containing the two organization views. The refrigerator IoT sensors use their API to send data. All transactions sent to the blockchain first pass by an orderer node that validates them. The Fructus process consists of 6 main sub-processes. In the first sub-process, the exporter creates a shipment and sends it to the refrigerator. In sub-process 2, the refrigerator receives it and verifies that the received amount of pallets corresponds with the declared by the exporter. If the verification is okay, the shipment is sent to cooldown, where the temperature is dropped slowly until 0 degrees Celsius. The cooldown process is very sensitive to failure. An operator must enter every 2 hours to rotate the pallets since the temperature is not equal inside the refrigerator. This is one of the reasons why Fructus IoT was developed, to assist in the detection of human errors. Once cooled down, the shipment is sent to a freezer until it is dispatched. If the pallet amount is not equal, the exporter is notified and the process is restarted. For this work, we have created two sensor types. The first one is a temperature sensor that has a Node MCU microcontroller and a digital thermometer. It has a Wi-Fi module to send data and a QR code label to indicate its identifier. The second sensor type is a movement sensor. It has the same microcontroller and a magnetic door sensor. The QR label allows the operator to easily pair it with the blockchain and shipments. For the purpose of this demonstration, we will be using a sample shipment pallet with the identifier SH004. Every shipment pallet must have the same QR identifier label, so operators can manage and pair them easily with the blockchain and sensors. In the exporter view, we can see that we have shipment assets and also new shipment transaction and assigned shipment transaction. If we click on the shipment assets, we can see all the shipments already created. Now, let's go back and create a new shipment. For that, we click on New Shipment Transaction. In this view, we can see two fields, Shipment Identifier and the amount of pallets of the shipment. If we click on the QR icon, we can scan the identifier from the shipment pallet. After that, we can manually enter the amount of pallets of the shipment. Upon successfully submitting the transaction, we will have created a new shipment. As we can see here, we have a new shipment with the created label assigned. It has no reception date and no reception pallet amount. The next step is to assign the shipment to the refrigerator. For that, we use the Assign Shipment transaction. Again, we scan the shipment QR code and manually enter the refrigerator identifier. In the refrigerator assets view, we can see that it has assigned the newly created shipment. The next step is to confirm the shipment reception to the refrigerator facilities. After identifying the shipment with the QR code, the operator declares the amount of pallets received. Upon success, the operator receives a notification indicating that the shipment is ready to be sent for cooldown. In the Assets view, the operator and the exporter can see that the shipment was receptioned and the amount of pallets was the same as declared. After a successful reception, as indicated by the notification, the shipment must be sent to cooldown. Once more, in the Assets view, the operator and the exporter can check that the shipment is in cooldown. The refrigerator can see their sensor assets. In this case, it has only one deprecated temperature sensor. To add a new sensor, the operator must use the new sensor transaction. The first step is to scan the sensor QR identifier code. After that, the operator must enter the sensor type, automatic or manual, and the sensor data type, movement or temperature. We will add a movement sensor used to monitor the door of the refrigerator. As we can see, we have our two newly created sensors that are disabled and has no shipment assigned. To assign a sensor to a shipment, we use the Assign Sensor transaction. Here, the operator scans the sensor QR code and the shipment QR code. After that, when powering up any assigned sensor, it will send data that will be associated with that specific shipment. Any sensor can be disabled to use it on other shipments. As we can see here, the sensor AT001 was disabled and has no assigned shipment. The exporter can see that the shipment SH004 is in cooldown. He can see the movement and temperature events stored on the blockchain. Every data point shown here is stored safely on every peer in the network, and it was uploaded to the chain using sensor, so non-interested user could insert fake data. After successfully cooling down the shipment to 0 degrees, the refrigerator can send the shipment to the freezer. The freezer step is the last one until the shipment is transported out of the facility.